Flack math! Give me some math and I'll give you some flack. Flack math!
Start. We're going to talk about Cramer's rule. Apparently some dude named Cramer thought of this. Using matrices, you can solve for a system of equations. Okay, I'm gonna, we don't talk about elimination method yet, but I'd like to do that just so you can kind of understand why we're using matrices to figure this out. Okay, so I'm gonna put a system of equations up here. 3x plus 2y equals -1. 4x minus 3y equals 10. Okay? Now, do you guys remember solving by elimination? Avery, you mentioned it. Like, if this was a 3y, like a positive 3y, what would happen when you added those equations together?
There would be no more y.
Yeah, the y's would be eliminated. That's why they call it elimination method. But it's not a 3y, it's a 2y. So, and then you ask yourself, well, can I multiply that by something to get, well, you could multiply by 1.5 to get to a 3y. And remember, you can multiply it by whatever you want as long as you multiply the whole side by 1.5. Well, that's going to be confusing. Or we could multiply both of these by something and then realize they're opposite. So what can I multiply by this and by this so I end up with the same number that are opposites? You guys remember this? Is that a no?
Do they have to be multiplied by the same number?
No. No.
Okay, then you could just multiply 2 by 3 and 3 by 2.
Yeah, so if this is kind of like
Okay,
finding common denominators, right? So if you multiply this whole thing by 3, and then we multiply this whole thing by 2, look what happens. So let's do that. I get a 9x plus 6y equals -3. And that's perfectly legal, right? As long as you do it to both sides, you can multiply whatever you want. And then over here I get 8x minus 6y equals 20.
Would it be 9x?
It's 2 times 4, 2 times 3.
I don't know why I thought you were still doing the top one.
So now when I add these together, I get, those cancel, I get 17x equals 17. So x equals 1, and then you can plug 1 in for x into one of those equations and find y and go from there. That's the elimination method. I would probably use the elimination method on this rather than substitution, because look at the pain it would be to get one of these variables by itself. You would end up with a fraction. Whichever variable you choose to get by itself using the substitution method, you would get a fraction. And we don't like fractions. Yes?
So you don't solve for y at all?
No, we're half done.
Okay, that's what I was making.
Yeah.
So then you just like plug in x.
Yeah,
and
you
find
can plug
y.
in there, so you get 3 plus 2y, so y would be -2.
Okay.
Okay, and make sure it works there. 4 minus -6 is 10, that works. Okay, so that's the elimination method. Now the Cramer's rule is very similar to that. So let me show you the Cramer's rule. And I'm going to use these numbers first in order to demonstrate it. So, x. You can find out x right away by doing this math. Okay? So x equals the determinant of this matrix over the determinant of this matrix. Okay, so let's just do, here's the matrix that we're looking for. So we want E, B, F, D. So we want this matrix right here, but it's reversed. So it's like -1, 2, and then 10, 3. And then over this matrix, A, B, C, D. So A, B, C, D is just this matrix right here. 3, 2, 4, negative 3. These are just the coefficients of those variables and the constants. So see how you can see a 2 by 2 matrix there if you just look at the coefficients? And see how you can see a 2 by 2 matrix there if you just look at the coefficients and the constant? 2, negative 3, negative 1, 10. And here's another one. This is what we'll use when we find y. And then y equals this. So x, if you cover up the x's, the top is this, the constants on the left side, and then the y coefficients on the right side. And then the bottom is always just this determinant. When you cover up the constants, it's just this matrix, 3, 4, 2, negative 3. Okay, so y, I'm going to cover up the y's, and I'm going to say, okay, that's negative 1, 3, 10, 4, all over that same matrix, 3, 2, 4, negative 3. No. Darn it. Sorry. This is not reversed. But the x is. I don't know why. Okay, so when you're doing the x, it's this column first. But when you're doing the y's, it's just how it's written. 3, 4, negative 1, and 10.
How do I remember this?
You'll kind of see what's happening.
Just do the other way and still get the right answer?
Yes,
Okay.
yes. Cramer's rule, and if you want to use Cramer's rule, you can, but you don't have to, even on a test. All right, so this, I can find the determinant of this, right? The determinant, what's that equal to? Negative 3 minus 20, right? What's negative 3 minus 20?
Negative 7.
No, 23.
No, negative something. I don't know. I can't do it on my head.
Negative 3 minus 20 would be 23. Negative 1. Shoulder keeps popping.
Sorry, this is the negative 3. Because, see that
Negative 3.
coefficient
Oh,
there?
so it's positive 3.
Yeah, so 3 minus 20 is
17.
negative 17. Okay, all over, what's negative 9 minus 8?
Negative 1.
Negative 9 minus 8.
Oh, yeah, negative
Oh.
17.
Negative 17. What's negative 17 over negative 17?
1.
1. Okay. All right, let's do this stuff here. What's 30 minus negative 4? What's minus negative 4?
Plus 4.
So 30 plus 4 is 34. What's negative 9 minus 8?
Isn't it negative 8?
Negative 17, which equals negative 2.
Oh, no, that's an
Negative
arrow. I thought that
9
was a-
plus negative 8.
Okay.
Okay.
The end of the arrow there looks like
Right. So if you can remember this junk, then that's a pretty easy process because you're going to get really good at determinants. Okay, you're going to get really quick and fast. If you can remember the combinations there, then this is an easier way to solve for systems of equations. But here's why I did the elimination method first, because you can kind of see what's happening here, especially down here. It's kind of like finding common denominators and stuff. You're multiplying those together to get certain multiples, but it doesn't explain it completely why a determinant is a determinant, but you can see that, yeah, there is some multiplying and subtracting going on when I'm doing the elimination. So this kind of makes sense, but I can't put it together exactly why this is correct. Okay? So that's a normal feeling in Algebra 2. Yes?
How do you find y using the elimination way?
You could have, once you find x, you can find y by just substituting x, 1 in for x. Or you could eliminate the x's by multiplying this by like negative 4 and this by positive 3, and then you get a 12 and negative 12, right? And then you'll get the y, but then you have to plug that y in to get the x. So this part, the next, you're only half done when you get one of the variables. And from here, just plug in 1 for x to find the y.
Okay.
Okay? So that's the elimination method. We'll talk about the elimination method in its own separate special chapter. But let's try one more. So let me, and I don't even know if I want to bother with this, but if in these, so here's technically the Cramer's rule. I'm going to use letters, and this, if you want to use this, and I may decide to have this be an extra credit option on the test. Like if you're to solve a system of equations using the Cramer's rule, you can do it any way you want, or you can do it with the Cramer's rule for extra credit. Okay, so this is good to know. So in a system of equation, here's what it looks like: ax plus by equals c. dx plus ey equals f. So this is a generic using a, b, c, d, e, and f. This is what a system of equation looks like. On the top equation, the x will have a coefficient. If it doesn't, the coefficient is 1, right? The b is the coefficient of the y, and c is the constant in that equation. The same thing down here. D is the coefficient of the x in the second equation. So these are just the coefficients and constants. So the A, B, C, D, E, and F represent the coefficients and constant of the two equations. Okay. So the Cramer's rule says this: you can find x by doing this: C, F, B, E, all over the determinant of the matrix A, B, D, E. So see, this bottom matrix is always just the coefficients, and that never changes. Okay, and then y is A, C, D, F, all over A, B, D, E. Okay? So write that down. It's also in your book on page 107. Okay? You might see this. You might see a capital D. D just represents the matrix of coefficients. And this equals A, C, D, F, all over that same matrix. Okay, so now, if you're solving by elimination, Avery, and you get down to here and you're like 13 equals 17. Like if you multiply by 3 and multiply by 2, and both of the variables canceled, then you get like 0 equals 17. That classification is parallel lines. They won't have a solution. But if you cancel both of these variables and you get 0 equals 0, then that's actually a dependent equation, infinite solutions, because no matter what you pick for x and y, 0 will always equal 0. Okay? But 0 will never equal to 17. So that's how you can tell right away using the elimination method if a system of equations is consistent or inconsistent or things like that. Now, if you're using the Cramer's rule and you get something like this, if you get like -6 over 0, well, what does that tell you? Can you divide by 0? No. So basically, when the determinant the coefficient matrix, the determinant of the coefficient matrix is 0. So basically, it kind of makes sense. 3 times 3 minus 2 times 4. But if these are all the same, like if this was like, yeah, if these are all the same, then that matrix determinant would be 0. So if that's the case, then what does that mean when you try to divide by 0?
Calculator catches fire.
Yeah. It's undefined. So using the Cramer's rule did not provide a solution. Neither of the numerators is 0, so there is no solution. Okay? But if you get 0 over 0, then you have not just the coefficient matrix equal to 0, but you have everything else equal to 0, then that means it's an infinite solution. So this would determine no solution. Okay, so parallel lines. This would determine infinite solutions. Okay? So whenever you end up with remember what this answer is called? This is undefined. Do you remember what this is called?
Dependent something.
It's not. Back to Algebra 1. This is called indeterminate. That's what we learned in Algebra 1 before we talked about determinants and stuff like that. So it's impossible to determine if this is 1 or infinite, because you can multiply anything times 0 and it'll get 0. So see how there's infinite solutions. If I did this backwards, what divided by 0 is 0? 0 divided by 0, well, if you do that backwards, this could be 7, right? 0 divided by 0 could be 7, because if you go backwards, 7 times 0 is 0. Well, 0 divided by 0 could be 8. It could be 9. It could be any number. So see how that we can't call that undefined. We can't say there's no solutions. There's actually infinite solutions. So that's why we call it indeterminate, because it's impossible to determine a solution. All right, so this is Cramer's rule. Use it if you want. You're going to have some homework problems using Cramer's rule. Seriously, the hardest part is just remembering, and you don't have to remember when you're doing your homework, because you can use this. You can use this in your book, okay, or in your notes. Just plug in those coefficients. Make sure you pay attention to the negative signs, like I didn't. Okay? All right, try it. You might like it. You might prefer this method over every other method, especially when it's like this and there's not opposites right away. When I see like a 3, a -3, then my elimination drool starts to form in my mouth. And I want to eliminate. Okay? But if you get a situation like this, it might be faster just to use the Cramer's rule. Okay, you just have to remember which coefficients go where and which constants go where. That's it.